Hi, I'm Mike Deem. I'm a program manager on the WinFS API team. We're responsible for building the managed application programming interfaces for the WinFS subsystem that's going to be part of the next Windows release, codenamed Longhorn. The subsystem is a powerful extension or evolution of the file system that lets you store more than just files with opaque data. It lets you store content with schemas that have rich types, and we're providing a rich, powerful API on top of that. So let's take a look at what some of this code looks like. All right, so what I've got here is a fairly simple console application that I can use to step through the WinFS API code to give you some idea of how you program against WinFS. So the first thing I'm going to do here is actually start up the debugger, and then we'll step through each line. The first thing you do when you're programming against WinFS is you need to create an item context. An item context is kind of your connection to WinFS. The WinFS API takes on a much more database flavor than a file system API flavor. Traditionally, database APIs and file system APIs are very different. With a file system, you open a single file and you do I/O on the file, and then you close it. Whereas a database API, you tend to do a query, get a bunch of data, operate on it, and send the data back. Because WinFS is really a database, the WinFS API is a file system style API. So the first thing I want to do is actually search for all the documents, search over all the documents that I have on my computer. In order to do this, I use an object called an item searcher. Now what I'm doing here is I'm saying I want an item searcher for the document type. We can look at the object browser and see that the document type is a class that exists in the system.storage.core namespace. Documents are items. They're derived from the system storage item type. So whenever I copy a file into WinFS, WinFS goes ahead and creates an item that goes with that file. The item is an object that represents that file. And WinFS knows that it's more than just a file. It knows that based on the extension and some other things, it can figure out this is a document, and it can pull certain information out of that document and make it available in the object and make it available for queries. One of those things that is available is title. So essentially this is saying that there's a property on document that's a title. It's a nullable string. This is using the new generic feature that's going to be part of the would-be release of Visual Studio. So what I'm essentially doing here is saying I'm going to search for all documents. Then I want to filter this down where I'm only searching for documents that have a title that matches a pattern. I passed the pattern in when I called this API. And I said I wanted all the WinFS API, all the documents that start with WinFS API, or the titles start with WinFS API. So in this filter string, I'm referring to the property that's in my object. I'm referring to that title property, and then I'm doing a pattern match. The other thing I need to set here is this syntax here is saying that I have a parameter named pattern, and I'm going to set the value of that parameter to the title that was passed in to this routine. The next thing that happens is I want to execute the search. That's done by calling findAll. And what that does is essentially return a collection of all the objects, in this case document objects, that match the filter that I've specified. And then I'm going to enum through those results. And let's just run to this point, and we can look at the output of this, and we can see that I found 3 documents that match my query. I've actually got over 100 documents on this computer, and we've been doing testing with up to 50,000 documents to get the performance characteristics of WinFS just right. So the next thing I want to do is actually work with contact items. So documents represent a particular type of thing in WinFS. It's a file-backed item. It's an item that has actual files behind it, whereas contacts are things that don't have files behind it. So what I'm going to do here is I'm going to create some contacts. When you create an item in WinFS, you have to put it in a folder. WinFS provides some folders for storing certain types of data, for organizing it. So it's like My Contacts, My Documents, things along those lines. So I'm going to get the My Contacts folder. I'm going to create a child folder within that folder to put my example contacts in. And the way that I say that this new folder that I'm creating is part of this parent folder is I create a relationship between those two items. So I've got the parent folder. I'm going to add a relationship to the child folder. Everything in WinFS is about items and relationships. The way that you build up structures between items is by manipulating, adding, removing, and modifying relationships. So when I did this, I haven't actually saved anything in WinFS yet. If I did in a separate application, if I did a search and tried to find the example contacts folder, it wouldn't actually show anything up. That only happens when these changes that I'm making are just in memory, and they're only saved when I actually do the update, when I use the item context and I flush the changes to the store. But before I do that, I'm going to actually create some more items. So I'm not limited to just creating one item at a time and then flushing. I can create a folder and a whole bunch of items that go in that folder and then flush them all. So create person here. It's fairly simple. I have a person item. Again, this is one of these classes that's in the system storage namespace. There's system storage contacts, and then under contacts we've got all kinds of things. We've got organizations, we've got person, we've got parent-child relationships, we've got online presence information, groups. So what WinFS comes with is literally hundreds and hundreds of these types that you can go ahead and use in your applications immediately to represent all this everyday information that Windows knows about. So when I create this person item, it not only creates the item in WinFS, it actually, I can go through the shell and some of the neat new features that are in the Longhorn shell and actually look at the person items right through the shell. So the first step in creating a new person item is to create a new person object. I can set the display name for this person object based on the given name and surname that I pass to this routine. I go ahead and I also want to provide a full name for this person. Now, this full name's built up using the same things, the given name and the surname, but in this case we're storing them as separate fields. What this lets us do is execute efficient queries where I would say I want to find all the people with a given last name. If all we had was this string that concatenated everything together, it would be really hard to formulate that query or to execute it efficiently. And this reflects the idea that all the data that's in WinFS is schematized. So the properties that I end up with in these classes are based on the schemas that define the shape of the data that's in WinFS. Now, WinFS comes with a whole bunch of types built in, but you can create your own types, and we provide the tools that would generate APIs that follow these same exact patterns and work exactly like these APIs. So the next thing I'm going to do is actually add a telephone number to my contact here, to the person. And again, we've broken out the different parts of the telephone number, so I can do a query for everybody with a certain area code. Similarly, I go and add an email address to the person. And then the final step is I actually add this person object that I have to my folder. And again, that doesn't actually go to the database at this point. I'm just building up my in-memory structures. I'm going to add another person, exactly the same code. Next, I'm going to create an organization, and we'll look at that. And it follows exactly the same pattern. Create a new object. It's got a display name because it's an item. It actually shares the same e-addresses collection. E-addresses stands for kind of electronic address, and it's the way that we store telephone numbers, email addresses, IM chat addresses, what have you. And again, add that to the folder. Now, the fact that organization and person are programmed in the same way is kind of gets to the real value around the WinFS API. The idea that we can have all these types in the system, but because we generate APIs from these, and they're very consistent APIs, you can learn how to program against one type, and what you learn carries on to other types. So finally, I'm going to push the changes back into WinFS. So we've created the organization, and now we want to actually go in and save these changes. I talked before about how all the changes that I made, all those objects I created, aren't actually committed to the database until I actually execute item context update. So now we've done that. They're actually in WinFS at this point. And the next thing I want to do is actually go in and list the contacts that are in my folder. So again, it's a search, and in this case, I'm getting a searcher that's going to return contact items, but I'm limiting it just by the nature of this target searcher call here. I'm limiting it to only the items that are inside the folder that I'm passing in. So I've got my searcher. I'm going to execute the search, and I'm going to write out the results here. So we'll run to there. We'll switch back over to this, and you can see that I've created 3 contacts, 2 people, 1 person, and now when I list the contacts in my folder, I get 2 people and the organization. All right. So the next thing that we're going to do is we're going to set up some relationships between these contacts that I created. I'm going to indicate that the people I created are employed by Microsoft, by the organization I created. So the first thing I need to do is to get the objects that represent the organization and the 2 people. What I'm calling here is a method on the item context called find one, and that's a shortcut for setting up a searcher and executing a searcher and getting the first result out. Internally, it uses the same item searcher that we've seen before. So I get back these 3 objects. The next thing I want to do is actually relate the mic object to the Microsoft object as an employment, with an employment relationship. And by executing that, that occurs. Now again, it's not actually in WinFS yet. I've just created the objects in memory, and I'm going to go ahead and set a property on the relationship itself. It's quite common in WinFS that the relationship carries data. Relationships just aren't about saying 2 items are related, but there's actual data on the relationship itself. And again, I'm going to do the same thing to relate John and Microsoft. And then finally, I'm going to save these changes to the store as well. And then we'll look at the results of that. Again, I'm getting a searcher. In this case, instead of searching for the contacts in a folder, I'm getting a searcher for all the employees of a new organization. So same basic pattern. You look for these get searcher, get employee searcher methods, and you can use those. So I can enum through these, and again, let's just run to the end and switch over and look at this. So it found that I've related these 2 people together. Okay. The final thing that I've got to show you is just real simply how to delete delete things. In this case, I just want to remove the folder that I created that has the contacts in it. So I'm going to step into there, and I'm going to go ahead and do that. I've got my personal contacts folder, and I'm going to remove the example contacts, and then save those changes. And the final thing that I have to do is close the connection that I have to WinFS. And that's it. Okay, so what we've seen is a brief example of how the WinFS API works. Gives you an idea of the flavor of the API, the fact that it's strongly typed, it's a high-level API, a lot of power without writing a lot of code. We're continuing to improve this API, and we expect to make it even simpler and more streamlined and more usable before we release. I hope you enjoyed seeing this sneak peek at what we're working on. Thanks a lot.